When you think about designing the ship to be fully autonomous, you're actually reducing the complexity. Most of the complexity is tied to two things. One is the navigational autonomy. And then the second part of it is, you've got this floating power plant. How do you go to automate all of that? This was the first time, I believe in military history writ large that something like this had happened, like an unmanned system is, participating in a combat search and rescue. The most important thing is that two of those Apache pilots are safe. The work really matters. There's not just contracts or demos or whatever at stake. You never really know when that could make the most important difference.
Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Vibhav Altekar, co-founder and CTO of Saronic Technologies, the Austin-based autonomous surface vessel maker that just closed a $1.75 billion Series D round at a $9.25 billion valuation. Wow, well done. And whose Corsair drone boat recently helped the Navy pull off the first ever rescue of a downed aircrew member by an unmanned vessel near the Strait of Hormuz. So this is going to be a great podcast. Vib, thanks so much for joining me today. I know you got a lot going on, so this is super special.
Yeah, thanks for having me, Dave. Excited to be here.
So this will be fun. So let's go a little bit about your background. Very much a research kind of background appears, and then as you 4 years at Anduril, rising, kind of the engineering management position for perception, and then walked away to co-found Saronic. Lots of other, journeys along the way. What led you to, the lessons that you learned as you were going through this journey of research and Anduril, and why you decided it was time to jump over to maritime autonomy?
Yeah, that's a good question. I think, when I was in college, I think, there's just a lot of exciting things to go and work on. I actually started off, even when I was in high school, was really focused on energy research. And so I was super passionate about kind of renewables, electronics, photovoltaics, things like that. I grew up in the Bay Area in Silicon Valley. And so kind of software and programming was always this kind of background skill. It was all we learned at a pretty young age in elementary school. It was kind of always the de facto skill that everyone kind of had just going through school in the Bay Area. So I was always interested in energy. I ended up getting really fascinated by self-driving cars, as that boom kind of took off post 2012. And actually, I found myself working right before Anduril. I was actually working at 8VC, which was a venture capital firm in San Francisco at the time. They since then moved to Austin. But that's really when I was exposed to kind of some of the macro details on why companies get backed, why they get funded, why some are successful, some aren't. What are the kind of, both political and economic factors that go into building a technology business, which I thought was really fascinating. And so I was actually at 8VC around the time that Anduril, I think, was raising their seed or Series A or something like that. I was working on, looking at technical deals at the company, at the firm, but also working on incubating a enterprise software business in the financial services space. And ended up jumping from 8VC going over to Anduril. Was just fascinated by the concept of, a lot of technology being built for national security and some really, really important missions and extraordinarily large budgets. But, it was at a time where, the great technology companies in 2017, 2018, like the Googles, Netflixes, Apples, Amazons, Microsofts, were pretty hesitant about getting into that space. And so, it's just fascinating to see a company that was nope, you know what, we're going to take the same talent, but we're going to do it anyway. Ended up finding myself at Anduril. It was fairly small when I joined, sub 50, 100 employees, and working on the tower at the time. And over the next 4.5-ish years, touched a bunch of things from counter UAS to drones to UUVs and autonomous submarines, all sorts of stuff. Worked a lot on the perception side. And then it was summer of 22. I was still in touch with a lot of the folks at 8VC. Dino Mavroukas, our CEO, was an EIR there at the time. One thing led to another, and I ended up starting the business at the end of 2022, early 23. Moved to Austin.
So was autonomous kind of naval vessel or maritime vessels something that interested you, or is it just generally the thesis of getting into a new business in the defense tech space? What kind of drove you there, or just a culmination of all?
Yeah, I think I personally have always been, I've always been interested in building and engineering, but for whatever reason, the business case or kind of the the infrastructure that surrounds the technology always interested me as well. Like I never wanted to work on something that, never made it into production or, never was a successful product or nobody used it. Like a core part of like the fun part of engineering and robotics to me is that people use it and it's useful and it's fun and it's exciting. It makes money, all of those things. And so I think for me, a large portion of it was like, listen, there's a lot of robots you can go and build. Some robots will be more useful than others, right? Like we could make, desks that roll around so that everybody has a desk, a hotel desk that moves with them, or like, you have those like, walking treadmills, for like people that want to like walk while they're working, all like home robots, all these things. But I think for me, like it was a little bit more interesting to work on something where it just has impact. It makes it into production. It's used widely and provides value. I think there's this like I think maybe it was Elon who like to kind of describe this, but like successful businesses either provide a lot of value to a small group of users or incremental value to the masses, right? And I wasn't necessarily picky on which one. I just wanted to make sure that we provide some value, right? And so I think from the naval vessel capacity standpoint, I think the things that intrigued me, and I think that it intrigued the team at the time in 22, and this was like, by the way, this was about 6 months before a lot of the videos were coming out of Ukraine, with the USVs kind of hitting the naval ships. I think the thing that was intriguing was why don't we see this in mass when we see self-driving cars here in Austin, right? Like we were seeing Waymos, we were seeing cruise vehicles at the time, Teslas obviously driving themselves, but why is it that like large ships aren't autonomous and they have technology from the 70s and 80s? Why is it that the destroyer still needs hundreds of people to operate? But even from like small fishing boats, like why is it still so manual? Like, I mean, there's just why are boats just these giant money pits, or even from a commercial and leisure perspective? So I think there's like a lot of different factors there that went into it.
Yeah, that is fascinating. I thought you should bring it up. Boats, it's not like they're driving along a road where you have very little, quick reactions that are required to keep it safe, but they're all old school technology. That's a great part. So yeah, you hear about Dino. So Dino, tell me a little about him. I think it's SEAL Team 6, CEO. You're the technical, he's not. What did that look like? Where did this idea that he came, if you can share a little bit about the kind of the founding story that you decided to join with him, and then how does it look when you divide it up day to day? How did you guys tackle that early on?
Yeah, so I think I think the early phases were really like a lot of ad hoc conversations that slowly kind of built momentum over time. It started off with like, maybe this will work, just kind of keeping in the loop. Maybe this is going to happen. I knew a lot of the other folks at ABC, so they kind of introduced me to Dino. Came down to Austin a couple of times. I think Dino and Rob had met on a hunting trip. And so Rob's our chief commercial officer. He was, former Marine, former registered lobbyist. He spent a lot of time on the Hill, and got a chance to meet him and kind of, share some thoughts on like, kind of like, what does this, it's a new concept, right? To only kind of shoot for firm fixed price contracts, to be venture back, take the risk on your own in defense, like still fairly new, go to market motion. And oftentimes in business, like your business tends to mimic your customer. And in this case, like you kind of diametrically oppose, right? Like the government is actually still used to doing things a fairly legacy way, except for like some organizations like DIU and things like that. But what does go to market look like? So we were just sharing notes and things like that, and just kind of chit chatting about what's hard about it, what's hard about the Navy in particular. What are some of the challenges there with like building products in the ocean? And then finally, I think the nail in the coffin was Doug Lambert, our COO, who spent the last 15 years in specifically maritime robots, which is, at least in 2022, is a fairly niche thing to only spend your career in. But he had just exited liquid robotics to Boeing. He was at TerraDepth, which was like they put 30-foot UUVs, like diesel electric UUVs. Yeah, he's our COO, and so kind of the nexus of all four of us. It was interesting because everybody has a distinct skill and kind of focus area, but there's always two people that overlap. And so you always have this kind of like you always have one person to kind of go back and forth over, right? Like Doug and I are both engineers, but Rob and I both spend a lot of time speaking to customers, go to market. I run the forward deployed and product teams. And so we spend a lot of time making sure that meeting customer requirements or kind of getting ahead of them. Rob and Doug both have spent a lot of time doing naval work in the past, working with those government customers. but also in like kind of the big ship arena, right? Like the challenges going from small kind of automotive scale robotics to shipbuilding is vastly different. And Rob has worked in the shipbuilding sector before. And then Dino kind of spreads across all of those things, right? Like Dino technically was a computer engineer back in college, although doesn't talk about it too much. But spends a lot of time doing government relations, a lot of time talking to customers, but also spends a lot of time internally, focused on operations across, recruiting, finance, government relations, things like that. So yeah, that's kind of how it all came together.
That's pretty neat. What's one decision from those early days that you would point to as kind of a real inflection point?
Some of the minutia around, the first 10 employees always has a pretty significant impact. And first 10 to 20 employees like always has a really significant impact because, the culture is downstream from them ultimately, right? And so uh, you know, our third hire was our head of manufacturing, our VP manufacturing now, John Morgan. He spent 10 years at SpaceX. He took the Raptor engine from only once every 6 months to once every 3 days. But as a third employee, we didn't have anything to manufacture yet. We hadn't designed anything yet, and so there's no point in setting up like supply chain infrastructure, inventory management when you're like 6 people in a garage, right? 7 people in a garage. And so he was actually our first mission operations person. And so like, I'm not an experienced, you know, boat person by any stretch of the imagination. Like it's honestly dubious if I can even swim well. Maybe that's why I'm in charge of the software. So nobody has to go out there and experience the ocean directly. But he was actually our first mission operations person. So when we were iterating on software on our like first prototype boat, John, now who's runs 1,000-person manufacturing organization, at the time his sole responsibility was make sure that I don't get I don't drown in the lake while we're testing software. So he was like one of the first operations focused people. I think in our first 20 or 25 people, we hired our first supply chain hire, who was like excruciatingly focused on making sure we have great supplier relationships. We're planning for getting economic order quantities and kind of like discounts at scale, and kind of understanding all of the things that are going to be important when you build hundreds of products a year. So those are some pretty critical decisions that, looking back, like, glad we made them when we did. I think there were some others where we were like, maybe those are the wrong points of time to invest in technology like this. And for some things, it was like, hey, we should have invested in this a lot earlier. A couple of good examples here are really tied to, what parts of the stack you really want to own yourself, right? So as an example, if you think about, buying thermal cameras, most thermal cameras don't come in enclosures that you can put them in the ocean. Like they're not meant to do that. And they're also pretty expensive. So you don't necessarily want to do that. And so at what point do we go and like outsource the assembly process, the calibrations? What point do we bring that in? How much more ownership of the quality at the end when we hand that product over to the warfighter? How much of that do we want to own and absorb ourselves to make sure that it works well? How much of that are we okay with like containing to a supplier? So like for some things it varies, right? Like, we're not going to make any modifications to, I don't know, an aluminum bar that we have on a particular product, or a piece of aluminum, but maybe specific areas that aluminum quality actually really matters a lot. And so we do care about it. Similar thing with sensors and kind of commercial off the shelf components. At some point, we kind of want to play that we'd be able to dial that rheostat, to make sure that we just own the quality and make sure like things are going to work the way we expect it to. Because we're not going to expect suppliers to throw all their cameras into the middle of the ocean, because we're going to do that for them.
Yeah, I think, those first 20 hires definitely matter for sure. So Dino has said that you guys are rethinking the entire ship, designing from autonomy from day one versus using older or existing hull designs. So from your role as a CTO, what does that change about how you architect there's a vessel versus how a normal shipbuilder may think about it?
Yeah, I think there's kind of the headliner kind of macro view, and then there's all of the details that kind of come to fruition. So the headliner view is that when you look at a large ship today, there's a large portion of the time that it takes to build, from safety standards to the parts, the materials to the assembly. Large portion of that time and material is associated to living quarters and designing for humans on board, and making sure that humans have the right levers to pull, sometimes literally, sometimes metaphorically, to ensure that the ship goes and does exactly what it's supposed to do, or the humans on board the ship have all the flexibility that they need. When you think about designing the ship to be fully autonomous, you're actually reducing the complexity. You're not increasing the complexity. And the reason why we say that is because when it comes to the amount of materials and time that it takes, you actually have less things to worry about, right? You don't have to worry about bathrooms and kind of plumbing for humans, right? You don't have to worry about a separate electrical grid that's focused on, 110 volts for people to charge their cell phones. You have to worry about microwaves and kitchens and stoves and all of those things, right? Um, you don't have to worry about making sure that you have, those fancy doors so that like, you can open them regardless of like the pressures and all of that. Like there's so many complications that are complexities that are isolated for humans. So you can get rid of a lot of those, right? So then the question becomes, okay, where are you collecting that complexity on the other side? Well, most of the complexity is tied to two things. One is the navigational autonomy, right? All of the things that you kind of hear in the news today, right? Like how do you operate in GPS denied conditions and with spoofing? How do you have really good ATR and AI models to detect things in the water? How do you make sure that your coal regs compliant? All of the kind of maritime autonomy buzzwords. And then the second part of it is, you've got this floating power plant that is what the humans were actually there on the ship to manage, which is the switchboards, the valves, the pumps, freshwater systems, the engines themselves, maybe the jet drives or the propellers or whatever it is that they're there to kind of focus on. How do you go and automate all of that? Or rather, how do you make sure it's observable enough and you have the right endpoints in such that even if it wasn't fully automated, a human still can click a button and do the same thing that they would have done when they were standing right next to the engine itself, right? And so that's where basically you're collecting the complexity, and the place where you're removing it from is like the time to build, the number of materials, and kind of the assembly of the vessel itself. And there's like a bunch of other optimizations you can make, right? Where if you look at the boat behind me, the Corsair, it would be a fairly unpleasant experience on a 24-foot boat if you were using that thing going at 40, 50, like 30 plus knots, and because it can turn a lot faster than a regular boat. It's meant and designed for sea states that are much higher than what regular 24-foot boats are designed for. But there's all of these technical optimizations that you can make when you don't have to worry about safety of the human on board. And so there's that's kind of like the headliner piece. I think the devil is always in the details, right? Well, let's think about Coast Guard regulations, right? Like what are the current regulatory policies? Okay, well maybe you're going to need like a removable man control module in some of these cases, right? And so we still need to make sure that like we have the right infrastructure for if somebody needs to be on there, they can, but you need to make sure that it's designed for it to be fully autonomous as well. So like how do we go and kind of cut that, like basically split that across those two kind of situations of like maybe close by, we need to have somebody because the Coast Guard requires it. On other missions, the Navy won't require it. So how do we kind of play that against each other? There's other things as well when it comes to the details, right? Like when it comes to a lot of these components, historically they weren't designed for a software layer. So they haven't necessarily exposed all of the details when it comes to, minutia around firmware or, certain nominal behaviors. Like it's not designed for that. And so like those companies don't necessarily think of it as their first, as like first or second nature, because they're not necessarily software companies, right? They might be a jet drive company or an engine company or a generator company, whatever it might be. And so working with those suppliers to really get it to the point of like, hey, these are the software inputs that we need to ensure safe and reliable operations. Like, let's work together to kind of get there. And we've done a lot of that, on a lot of the parts with Corsair, where we've worked really, really closely with the vendors to be like, hey, this is going to be fully autonomous. So no humans going to be touching this thing for sometimes 30 days, 40 days. We need to make sure that we have all the software observability we need to ensure safe and reliable operation. And so we work with them on things like that. So a lot of things are masked in the details, but that's really the headliner.
Yeah, I mean, that's pretty big, a pretty big decision to go build all that, right? How was it convincing early VCs and it is definitely capital intensive. How did that look in the early days, raising capital, getting to, I imagine you did a prototype and then tried to scale, how did that kind of journey look from like capitalization?
Yeah. So I think, from my time in VC and then, you also going through the fundraising process a couple of times, I think there's a big difference between like the early stage and kind of the growth stage. I think early stage, a lot of it has to do with like, are you well connected across the network? And have you assembled the right team, and can you tell the right story? Is there a market that exists to go and capture here? And I think Dino's a phenomenal storyteller. I think him himself, his personal story is very inspiring. Going from New Jersey to going to the SEAL teams, to going into private equity. Like it's just it's an inspiring story in itself. I think in the early days, it's about kind of ensuring that really validating like is there really a market to go after, right? And I think the Andurils, the SpaceXs, and the Palantirs have really proven out that it's very difficult, but it is possible to have good margins and sell to the government. It is possible that maybe a venture capital as an asset class is able to go and fund public sector businesses that can be successful. And I think SpaceX and Palantir, in particular, have obviously have a large portion of their revenue that comes from the commercial side. But Anduril did a really great job of kind of proving out that thesis and scaling very rapidly. I think the big question was like, is it important to go and focus in this area, build a technical moat, build a production moat? Really, manufacturing is one of the biggest pieces that I think a lot of the companies in the United States still are especially the newer companies still struggle with. It's very difficult. Elon talks about production hell all the time. And then I think it changes as you get to the growth stage, right? At the growth stage, the investors are a little bit different. Their calculus is a little bit different. The checks are a lot larger. And so what they're really looking for is like, good unit economics. Is this going to scale? Is this going to compound at scale? Is the value enduring, right? Can somebody just show up and start building ships and take away market share? So there's a lot of other things there. So I would say, and we've been blessed and grateful to have like a fantastic set of investors to back us from the very beginning, from 8VC, Joe and Alex over there, to Andreessen, to Caffeinated. A lot of like really, really great firms from the seed and kind of supported us, through the later stage rounds that we've had another great set of investors come on and lead those. So yeah, it's been great working with all of them.
Wow, that's cool. So get back a little bit more to the plot, you guys are building. So some of the, obviously, swarming is now a buzzword. So, you talked about boats, getting rid of that driver, if you will, sailor, automating that, and then going to like this idea of swarming. How do you look at it, and were there design trade-offs when you were approaching that, that problem?
Yeah, so this is an interesting one because I think a lot of times the definitions of these words kind of change depending on who you talk to, right? Let's say, if somebody hasn't been in a Tesla or Waymo before, they might look at autonomy as like, oh, I've told the boat to go from point A to point B and then B to C and D to E and then come back home and it did it. And great, that's autonomous. And then you might talk to someone from Silicon Valley who's worked at those companies, and autonomy means something totally different. Autonomy means translating intent into action. And like kind of no human in the loop, no human intervention, right? Where like now in your Tesla, you can just say like, hey, take me to the closest Taco Bell and I'll just go do it. And so I think autonomy in that lens kind of means a bunch of different things. I think on the government side, you kind of have a similar distinction where, you have this kind of like tier one level of autonomy, which is kind of like same thing, like A to B, B to C, and you kind of click buttons to get there. But then there's also this policy distinction around, autonomous weapon system standards 3009 that the DoD published. So you have these varying definitions, which makes it a little complicated to kind of narrow in on one, because depending on who you're talking to, it's a little different. But I'm happy to go through like the way that we think about it. So number one, for this kind of multi-agent collaborative autonomy, the swarming kind of capability, there's a couple of core primitives that we think about a lot. Number one is that good swarms, good collaborative autonomy first requires intelligent agents. And I think about it, like there's a Coach K, the famous Coach K analogy, right? Like, if my players aren't good, if I'm coaching a middle school football team and they can't run plays, they can't really throw a spiral yet, or like, whatever. Even if I'm Bill Belichick, like I'm not going to take this team to the championship, right? The players first have to be good. We need to first have intelligent agents as being independently good. So what does that mean? That means that my assets can operate in comms denied environments. That means that they can go silent if they want, and they have the ability to go passive and active. That means that when I translate intent for them, they understand what that is and they can do it in a reliable way. Like I'm not worried about the boat having issues on the way there, right? It means that it's observable to me. So if there is, network health issues right in the middle of the ocean, you have bad weather, sometimes you can have bad comms. There's all these different things that can go wrong. But the intelligent asset would tell me directly, hey, I think this cable might be a little funky, and I think in this region my comms are a little spotty. Other than that, I'm all good, right? Intelligent agents first. If all of my individual agents are good, then my strategy starts to make a big difference, right? Because now I can start to I can do resource contention. I can allocate resources differently. I can have couple payloads here, a couple payloads there, and then the intent is use payloads in this way here, use payloads in that way there, and then give me this kind of a whole situational picture of what's going on and feed it back to me. I can say, hey, go silent. And so like maybe I don't have comms, and then they'll go do something and come back and give me all the information that they've collected, which can be strategically advantageous. But really that's the strategy, and the multi-agent piece starts to matter when the individual agents are good. And then the core part about the multi-agent piece is that, it's called multi-agent autonomy, or a lot of people call it collaborative autonomy. It's less so an autonomy problem. It's more of a distributed systems problem. It's all about like, which of my assets are communicating right now and at what rates, and which ones aren't. And at the end of the day, in a really, really contested environment, if none of my assets can communicate with each other, but I'm trying to use them in a collaborative way, what happens? They're back down to their individual primitive, right? And then it just boils down to how intelligent is one asset. And so that's kind of the way that we think about it, and you kind of think about it in the way where like, you're running an ISO play in basketball, like all of your players are still back court, but ISO play, someone's got a fast break. At the end of the day, like strategy matters less at that point. It's like, is that player good enough to take it in the paint? And if they score, they score. So that's kind of the way that we think about it internally. A lot of sports analogies and metaphors, but really translating back to intelligent agents. Like you need to have the individual robot be really good first. Then your collaborative autonomy can exponentially increase the value of the fleet. And then 2 is collaborative autonomy is really distributed systems and networking problem. And in the ocean, that's really hard because salt water on your antenna is going to hurt your quality of service. The ocean's just a tumultuous place. So forget like contested RF and jamming. Like the ocean itself might try to hurt your comms in the just on day one, right?
That makes sense. I mean, well broken down. Is that not how many other folks are looking at this autonomy that you've experienced, or are they looking at it differently?
It's hard to say. It's not common for for a lot of these things to be like well shared or well gossiped. Oftentimes there's different places where people put their focus, right? Sometimes people put a lot of focus on, the software part of the network stack. So maybe they're focused on like layer 3 parts of the network stack to optimize for packets going from point A to point B. Some companies focus solely on the antenna side, right, and the RF side of things. They're like, okay, we're going to go with some more specialized radios, or specialized antennas, things like that. So it's a hard problem. It's a confluence of a lot of different things. We try to ensure that both from a software perspective and a hardware perspective, we can swap out or iterate to getting to what the best solution is at that time. And then, we've just collected a lot of data. We've built over 300 Corsairs to date, and it's just, every single one of those Corsairs that hits the water, just collecting a lot of data. And so across all of the places we've deployed, all the places that we tested, that data really helps create that feedback loop. So whether it's improving AI models on one side, could also be helping improve that kind of network congestion and network problems on the other side.
And is the U.S. government on board with this philosophy? Was it resonating with them?
I think in some cases, yes. There's kind of a lot of different opinions that fly around for a lot of different parts of the technology stack. But I think generally speaking, a lot of our customers are super supportive, and a lot of the things have been proven to work really well. And so I think a lot of the times, like some of our early technology bets speak for themselves. One of the things that we took a really, really early bet on is that, like way ahead of a lot of the requirements, was that we wanted to ensure that all of our products can operate totally passively. So doesn't need active radar, don't need active comms. You've got enough compute on board, and just with passive sensing like cameras and things like that, you should be able to do all of your navigational autonomy. And that was a really early bet. It was pretty risky. We made sure that it was a little bit more expensive to invest in that when we were a smaller company, but it ended up being the right bet long term. And if you fast forward to today, I would say like most of the systems that most people are building kind of have to have some element of this as part of their kind of product features or roadmaps, just because when you get into some of these regions, this becomes a very contested area from an RF perspective. And so it just becomes really important to test and validate and build for that.
Great segue into government trusting you. So I mentioned it in the intro, your Corsair, participating in a rescue operation. I know you can't get into like operational details, but You know, what can you share about this? I guess in the first part would be, was this already being are you being operationalized, obviously, or was this more of just like I say prototype, but that's the wrong word, just happened to be in the right place at the right time?
First and foremost, the most important thing is like that two of those Apache pilots are safe. That's, I think, the best thing about this. That's the coolest thing that we could play a small part in. That was just great that was successful. I think I'm sure with a lot of the folks that have I've personally never been involved in combat search and rescue. I'm not a veteran, but for all the people that I've talked to and that have participated in these things, they can be very dangerous, be very scary. So we're just glad that it worked and those two guys are safe, and it's great. I think from the perspective of using USVs to do this kind of stuff, I think it's fascinating, right? This was the first time I believe in military history writ large that something like this had happened. Like an unmanned system is participating in a combat search and rescue. I think overall, if you obviously look at the boat, like there's no seats on it, so it's not like we'd specifically designed, hey, it's gonna be comfortable ride back home anywhere you go. Like you take it in Lake Travis or you take it in San Diego. Like it's obviously not meant to carry humans, but it obviously can be used for that. And I think it speaks to probably some element of the creativity of the folks that we have in our armed forces to find the best solution or find the closest solution or find the most efficient solution to make sure that they're solving the problem as best as possible. So I know there's plenty of infrastructure around combat search and rescue. Yeah, I mean, it was definitely a proud moment for the company, and it was really exciting to just hear that went well and when it was successful. And I think for the company, the week after, we just made it really clear that like, hey, the work really matters. There's not just contracts or demos or whatever at stake, right? Like the work really, really matters. It makes a real impact in people's lives. Like make sure we take that really, really seriously. So extra hour one day that you're spending working on something, if you can spend an extra 5% dotting I's and crossing T's, you never really know when that could make the most important difference. So yeah, we just really took that to heart.
Yeah, being mission aligned matters, but man, that really is something that you can hang your hat on and go, all right, guys, let's buckle up. So that's awesome. What did that affect at all, kind of the performance? And we don't know the details, but just at a big level, kind of human in the loop or human on the loop, like where some of those lines were drawn now that you saw it operationally do a pretty intense mission?
Yeah, I think, I mean, again, this boils down to like a lot of early engineering decisions, right? Like you cannot expect to always have, even if you wanted to design a system to be human in or on the loop, in challenging environments, especially in the ocean, it's hard to always expect that. Even when we're doing testing in, Galveston, right, or in San Diego, even if you always want the expectation of human in the loop or human on the loop, maybe you go under a bridge, maybe the radio payload stops working, maybe there's some issue that happens. Like you always have to plan for that scenario, and the software has to be intelligent enough to make sure that it understands, hey, this is what happened. This is my fallback. This is the next kind of phase of logic or execution that I'm moving into, and making sure that's really observable to the user. And all of the onboard processing needs to be cognizant of that, to ensure that's like right safety module, like right safety behaviors, etc. Whatever the mission is, the software needs to go and execute. So, I think human in the loop, human on the loop. Like I think that conversation happens a lot when it comes to like FPV or like what again, it goes back to our earlier conversation about like, how do we actually truly want to define like all the way from L1 to L5 autonomy? For us, we design our systems to be fully autonomous, right? So in the case where there is no human in the loop or on the loop, the platform is still designed to go and execute the mission. And then you have all of the kind of safety panels and bells and whistles at your fingertips to ensure that like, hey, if I do lose comms, do something else. Or if I do lose comms later or whatever it is, you have the ability to go and kind of translate mission intent into execution. And that's the kind of the way that we define autonomy. And so yeah, I think in these cases, even before thinking about how contested RF environments can be, and especially in certain areas, we never forget that the ocean actually just makes it hard enough already. So it's always it's a good place to start from, at least. Like you're not starting on easy mode, right? You're starting at intermediate and then you're getting to hard.
Yeah. Well, you've obviously built for this, but what's part of the problem that still doesn't have a good engineering answer? Are there some things that you're just like, man, this is, haven't quite figured out?
frankly, like a lot of the, across a lot of the technical problems that we solve internally, there's a lot of different focus areas, right? Some are external in the sense where the product facing, right? So whether it's, training end-to-end models for perception or, more efficient control schemas through the water to minimize fuel consumption or, minimize the G forces that you're taking in high sea states. A lot of different interesting engineering problems that are constantly being iterated on as we collect more and more data. There's a lot of things that are like purely internally focused. How do we have really good simulation and hardware in the loop infrastructure? So every time somebody's testing code, every night that code runs through a pipeline, it runs through a bunch of old data, it runs on representative hardware. And so that by the time you're ready to ship that code, you have confidence that it's like touched the hardware before, it compiles, it runs, it's run through a bunch of simulation tests, and we're ready to go on the water. We have a mantra internally where a new developer should be able to join the team, especially enabled with the superpowers of all these AI tools. On the first day, you should be able to write a new feature, be able to test it in simulation. Within 24 hours, you should be able to test it on representative hardware and maybe get a representative lake test in a small lake that we have in Austin. And then within 48 hours, you'd be able to test it in the ocean. So on a developer cadence like that, if like somebody can join the team, write a piece of software, and within 48 hours it's in the ocean, we need a bunch of infrastructure behind it to ensure that somebody's not taking a boat out into the middle of the ocean just to find out that as a layman's example, like they forgot a semicolon somewhere, right? And so built a lot of infrastructure on the back end of that. So there's a lot of focus that goes in there. And then the last piece is like we spend a lot of time building software tools to help production and manufacturing teams go faster, right? A core part of our business, like Corsair, is as a product barely 2 years old, but we've built over 300 units, like a couple of different variants. There's a bunch of different payloads that go on Corsair across a bunch of different kind of mission sets. And so we just built a lot of them. And so we build a lot of tooling to help our production and manufacturing teams as well, get supported in that process. So yeah, a lot of different areas. I would say the biggest unsolved problem, again, it goes back to the core challenge, right? The ocean's a tough place. So a couple of the things that we're working on is a lot of the kind of an advanced level of controls, kind of this like digital captain or digital coxswain kind of concept of what are the things that really really experienced mariners do in challenging sea states, and how do we kind of encode that knowledge within software on the platform itself, so you can kind of mitigate through challenging seas, reduce fuel consumption if you need to, but if the mission requires, like, hey, I don't care, just go in full speed, you can still do that.
Fantastic. Well, we're going to push that a little bit more to kind of what's next, where you see yourself going. You and Castilian, a pretty cool company, just announced plans to launch a hypersonic weapon off of a Marauder, your Marauder platform. What is pairing kind of an uncrewed launch platform, with a hypersonic, strike system? What are the challenges that? What do you think the true opportunities are?
Number one, it's just going to be one of the first time in history something like this has ever happened, right? So that'll be pretty exciting to kind of push the needle and kind of break down some barriers on the technology side. I think what we're really hoping for, and a lot of this has come downstream from what the Navy's kind of long-term plans are, is to complement the manned fleet with kind of this unmanned fleet that is capable of either the unmanned fleet can obviously sacrifice itself, right? They can be attritable if they want, but also they can force project, right? And so when you have this kind of distributed fleet of both sensors but also effectors, and especially effectors that are hypersonic, it can create a really really scary scenario for a lot of adversaries. I think a lot of great technical problems to solve. Castillion's a great team. We're really excited about the partnership there. And, I know that they've made like a lot of great technical improvements on their end of their part of the stack around, advanced seekers and their propulsion systems and all of that. So it's cool to see like kind of the marriage of like a bunch of different optimizations across these two separate fields kind of come together. And really the result there is the ability for the Navy to kind of call on these when they need to, either for force projection or, protecting manned assets. And I think it'll provide like a serious complementary value to the manned assets that we currently have.
Fantastic. Okay. So we have heard that your stated competitor is China's shipbuilding capacity. If that's the scoreboard, what does winning look like in 10 years?
Yeah, that's a great question. There's a lot of different factors that play in to competing with Chinese shipbuilding, right? I mean, this is not solely a technical problem. It is not solely a skilled labor problem, right? This is a kind of one, it's a problem of national security, but two, it's there's a lot of it has to do with economics, supply chains, and really the incentive factors and the incentive structures to go and get this done, right? There's a lot of interesting things that just happened in the last couple of months that point in this direction. One example is the 60-day Jones Act waiver, right? So we had 60 days where the Jones Act was parts of the Jones Act were basically temporarily waived as a part of what like the economic downstream impacts of what was happening in the Middle East. Um, that resulted in a lot of interesting things, right? So the Jones Act is basically a piece of policy that says all U.S. port to U.S. port traffic is done by U.S. made ships and operated by Americans. And so there was a waiver for 60 days. And so what we saw there was really interesting because it opened up a lot of different routes that historically just don't exist, right? A couple of examples of these are like I think there was like four times in just 50 days. There's like four times the amount of traffic that went from the Gulf to California as we did all of last year. It was just during the waiver. And so, I think as a part of that, coming back to the Chinese shipbuilding piece, I think there's one which is, what are the core economic problems that we're looking to solve on the commercial side, right? There's a demand for movement of goods, but the cost profile of the ship itself may not necessarily warrant that you need these like large manned crafts. Today cost hundreds of millions of dollars. On the commercial side, billions, obviously on the defense side, to do this work, right? So for us, what that looks like is great. You can build autonomous ships cheaper, and you can build autonomous ships faster. And you have a bunch of different kind of details at the edge that can kind of help, like your cost per TU could be a little bit lower. Um, you know, maybe the insurance premiums look a little bit different at scale, right? Like, it's going to be a long conversation from a policy perspective as well as with the insurance companies to figure all of that out. But again, competing with Chinese shipbuilding looks like solving economic problems, like solving real demand problems of solving challenges for operators, solving challenges for oil and gas. We have a partnership with a great company down in Louisiana called Hornbeck Offshore. We do a bunch of great work with them. And then the other side is, what are the technology investments that we want to make here, right? From robotic automation to better processes in the shipyard itself, right? A lot of shipyards, like, they don't have AC. Like, it's a lot of pen and paper. How do we get kind of the first generation of digital tools into the hands of operators in the shipyard, where it's like, I know exactly what I'm doing today. I can check boxes. I have badge in. I have badge accesses and kind of can track all the things that are going on. I have observability into where blockers are across the entire yard. I have infrastructure on the supply chain side. So if there's a part that's bad or whatever, I have all of the infrastructure around it to make sure I'm going as fast as possible. There's a whole host of things that we need to go in to go solve across economic demand and solving like real business problems to technology investments and then the infrastructure behind them. So, yeah, I think what this looks like 10 years from now, we have this initiative around Port Alpha where we want to build the largest shipyard geared towards autonomous crafts, in the world. And I think one of the big focus areas there is like the confluence of all three, but then also how do we get the right talent attracted there in the first place, right? Like, who is excited about this mission? And so there's a lot of different things that are going to go into that. But our hope is that over the next 10 years, we take a serious shot at the amount of capacity that those Chinese yards have. And yeah, they've accomplished a lot, right? And so it's going to be difficult, but we're excited to take on the challenge.
All right. So when we look at kind of the naval warfare side with unmanned surface, you're also playing in under subsurface, correct? Just let's talk about that real quick. Subsurface.
There's some stuff that we do subsurface. Yeah, I can't talk too much about the products yet, but I think what I'll highlight is that the air water gap is a difficult one. So if you want, let's just say like you have a UUV and you want it to talk to a drone, right? Something needs to convert those packets of light that are going from a radio on a drone down towards the ocean into packets of sound, and then and then have those get translated to the UUV. So you're basically going through this weird kind of conundrum where you're trying to send information from one node to another, but on one side it's sound and on the other side it's light, right? And so that's one of the big advantages of being at the surface of the water, and kind of one of the things that actually makes it really challenging is that at the surface of the water, you have to deal with both. You have to deal with wind, you have to deal with RF, you also have to deal with acoustics. And so, yeah, we've done a lot of interesting work around, how do our USVs play a role in kind of that node of the mesh network across UAVs and UUVs and things like that. Um, and I will say that, like, when you're in a single fluid environment, right? Like when you're UUV, the seasick doesn't affect you that much, right? Like you're not smashing into waves. Like you're not taking a bunch of G forces just by, driving forward. On the surface, you have that problem because, like, a wave, you might be stationary one day or 1 hour, and then the next time a wave kind of hits you and just knocks you somewhere else. And then in the air, obviously, like, flight is a well studied science as well. So, being at that surface really enables a lot of different things. And so, being focused on maritime means that, a core part of the technical expertise that we have to build as a company is around acoustic comms, acoustic sensing. And I think it's another one of those areas where, like, when's the last time you've heard about, engineers from Silicon Valley going off and working on, acoustic signal processing or communication via sound, right? Like, not really. I mean, like, one of the greatest companies of all time, I think Qualcomm, when they invented CDMA, like, I don't think any one of those engineers was ever thinking about, what would be a great idea if our cell phones, we kept the signals in the sound domain. They were like, no, we're going to convert sound digitally. We're going to convert into RF. We're going to go through this, these EM pipelines. So there's just not a lot of infrastructure, not a lot of investment that we've kind of, as engineers, like, put into this field. I think outside of the defense space, right? In the commercial world, there's not a lot of focus on acoustics. Obviously, a lot in defense, and so a lot of that research, a lot of that IP is kind of constrained to a lot of the kind of, defense labs and FFRDCs and things like that. So yeah, I mean, it's just a core part of what I think USVs will be used for in the future.
Fantastic. Maybe we'll wrap it up with this question. What do you think of kind of the naval warfare I talked about? What does a carrier strike group look like? And and where do humans play?
Yeah. I think it depends on the timeline. But I would say, like, probably in the, maybe not too distant future, maybe 10 to 20 years. I think generally speaking, in the short term, I do think that, like, there's a push from the Navy to enhance, a lot of the manned fleets with having these unmanned assets around them. Kind of, in some cases, they could be for, additional sensing for long range ISRT. In other cases, it could be for fires, as we talked about with Castellan. In other cases, it could just be as, comms nodes for undersea, right? There's a lot of different applications there. I think in the long term, I think a lot of the manned assets will also go through some of the digital refresh cycles, right? Like, maybe you'll have a, easier user experience inside the bridge. And so you'll need less people in the bridge. Maybe you'll need less people in the engine rooms because you'll have a little bit more digitization when it comes to the automation of the engine rooms themselves. And so my hunch is that a lot of the focus will kind of decrease on kind of just focusing on the maintenance and reliability side, and we'll really just focus on what, a lot of the sailors and warfighters and analysts do best, which is focused on, understanding threats, force projection, and actually doing the warfighting. So I think that's probably where this goes, where, like, a lot of the I'm not sure if, like, the people that, like, kind of sit in the engine room are super thrilled about it anyway. So I think as the technology gets better, I think they'll be going to, potentially a lot more interesting parts of the whole mission that they're part of. So yeah, at least that's the hope.
Well, Viv, this has been awesome. Unfortunately, I have to wrap it up, but I could keep going and going. If people want to follow the work at, Saronic, what you're building, or get in touch with you, how best do they do that?
Yeah, I mean, first and foremost, like, we're hiring pretty aggressively across the digital workforce and the physical workforce. So if you want to build ships or you want to write software for them, we are hiring. We have a bunch of open roles on our website. It's just saronic.com. And then, yeah, I think we've got reasonable presence on Twitter and LinkedIn. And so, yeah, I'd say that those would be the best places.
Awesome. Well, thanks so much. Super fun conversation, and let's stay in touch. I look forward to seeing you in Austin sometime.
Thanks for your time, Dave. Thanks for having me.